For the simplification purpose, we will make use of it. Third one is NPR upon NPR minus 1. Just I don't want to explain you that more, because by applying the formula NPR, you can simply get that whenever you come across such type of permutations. Third one, NPR divided by n minus 1 PR minus 1 is equal to n. Apply the formula and simplify, you'll understand it. Whenever you come across such type of numericals, you can write the answer directly, like if you have 15C5 upon, that is n is given to be 15, r is given to be 5, divided by 14C4. 14C4, that is 1 reduced here. In this case, what should be the answer? It should be the answer. 15 should be the answer. That is P, 15P5 upon 15P4. 15P5 upon 15P4 is equal to 15. This is very simple thing. You can understand that. Next one also similarly, NCR upon NCR minus 1. Fourth one, NCR upon NCR minus 1 is equal to n minus r plus 1 upon r. Simplify that, you'll be understanding that. Permutations of n distinct things, very important one. Fifth one, please. Generally, what happens when we work out the problems, you don't get the idea of this. That is why I have chosen this. Permutations of n distinct things, if the order of r things not to be considered, the order of things not to be considered is n factorial upon r factorial. Order of r things not to be considered means what? There are n persons. Let me say, those n persons are to give a speech. In the speech, generally, let us suppose a political meeting. In the political meeting, Prime Minister has come, and Chief Minister has come, and Home Minister has come, and President has come. And there will be some formality, there will be an order for those persons to speak. That means, well, first of all, Prime Minister should not speak before the President. So, President has to address something like that. Some protocol will be there. Some protocol will be there. In such a case, the order of those 4 persons is not to be considered among with the others. Among with the others. In such a case, what should be the permutation? Okay, let's have a problem on that one. Go to the previous slide. This one, there are 7 persons, and among them A, B, C are 3 persons whose order is not to be considered. Whose order is not to be considered. Whose order is not to be considered. Then in such a case, then how many permutations can be made? That means these 7 persons are to speak in a meeting, and in that one, ABC order is not to be considered. ABC order is not to be considered. ABC order is not to be considered. In such a case, how many permutations can be made? How many permutations can be made? See this one carefully. Now, this is 7 persons generally can be arranged in, just wait. See that one on the screen, please. Third problem. A, B, C are 3 persons among us 7 persons who speak at a function. The number of ways in which it can be done if A speaks before B and B speaks before C. What does it mean? A speaks before B and B speaks before C. It doesn't mean that A speaks before B means it need not be immediate. B speaks before C, matlab it need not be immediate. It may be placed anywhere. First A speaks, then only B speaks. B may be anywhere, but A must speak first, and after that B speaks, and after that C speaks. That means how many without restriction are there? 7 minus 3. 4 are there. 4 persons are there without restriction. Then ABC should be placed in such a way that if A is placed here, B must be placed in any one of these 2 places, because C must be accommodated. And if A, B are placed, C must have a place behind B. That means A, B, C can be placed anywhere in this blank places, but you must understand that they must be placed, they must speak in such a way that A speaks before B and B speaks before C. That means you understand it whenever you come across this type of problems. Understand that the order of 3 persons is not to be considered. The order of 3 persons is not to be considered. What does it mean? Then 7 factorial upon 3 factorial. Understand, very simple. 7 factorial upon 3 factorial. 7 factorial upon 3 factorial. So what should be the answer? You can imagine that 7 factorial is to be divided with 3 factorial. That is, it is 5040 upon 6. Simplify that, you will get the answer. So simple thing. I'll answer your question, Aishwarya. What is it? How many 3-digit numbers x, y, z with the x, comma, z less than y can be formed? Isn't it? We'll answer that. So understand, whenever the order of the things, 16th slide. So whenever the order of things is to be is not to be considered, then simply it is n factorial upon r factorial. Fifth one please. Permutations of n distinct things. If the order of r things is not to be considered, is n factorial upon r factorial. Next, sixth one is NCR is equal to NCn minus r. What does it mean? NCR is equal to NCn minus r means, what is the meaning of NCR? Let us suppose there are 30 students in your class, and from 30 students or 15 students are taken, or 12 students are taken. Let me say 30C12. The group of 12 students is to be formed. Then 30 students are sitting in the class. I have separated 12 students from them, and how many will be remaining? Then 30 minus 12 will be remaining. So that is 30C 30 minus 12. If I make a group of 12 students, automatically another group of 18 will be remaining. That means the number of ways of making a group of 12 students from 30 students is equal to number of ways of making a group of 18 students. Understand? So 30C12 is equal to 30C 30 minus 12. That is 30C12 is equal to 30C18. That is NCR is equal to NCn minus r. This is only used in the binomial theorem. You know that the binomial coefficients are like this: NC0, NCn, NC1, NCn minus 1, NC2, NCn minus 2. That means NC0, NCn are equal, NC1, NCn minus 1 are equal, NC2, NCn minus 2 are equal. You can understand that. That is why, basing on this property only, in the expansion, the binomial coefficients are used. Okay. Next, seventh one is important one. You can find some previous questions also on this one. NCR is equal to NCS, implies n is equal to r plus s, or r is equal to s. Understand this. N is equal to r plus s, or r is equal to yes. Okay. Now, these are some relations are to be remembered. Now, to answer that question of Aishwarya, we have to work out some problems on the combinations. After working out the problem, we will answer that question. It is the geometrical applications is the topic today. Geometrical applications of combinations. So what are the geometrical applications? Geometrical applications means, you understand, see that one carefully, the number of diagonals in a regular polygon of n sides. The number of diagonals of a n-sided polygon. Rather, I have taken 1, 2, 3, 4, 5, 6 hexagon I have taken. What does it mean? The number of diagonals means how many diagonals will be there for this one, joining any two sides like this. So how many points we need? How many points we need to form a diagonal? How many points we need to form a diagonal? Diagonal is consisting of anyway 2 points. So a six-sided polygon, that is hexagon, how many vertices it has? 1, 2, 3, 4, 5, 6. In this 6, we need a diagonal. Diagonal means it consists of 2 points. So I will choose 2 points. I have applied 6C2 here. Then you may think, why not 6P2? Not needed, because it's a line. It's a line. If it is a vector, then you have to apply P here. It's not a vector. Vector means AB bar different from BA bar. Different from BA bar. They are like this, you can say. Differs with 180 degrees. So these are not vectors here. If it is vector, you have to apply P here, but these are the lines. So 6C2, I say, 6C2 diagonals can be formed, but among them you understand, these 6C2 may be sides also. This is one side, this is not a diagonal, this is side, not a diagonal, this is side, not a diagonal, this is a side, not a diagonal, this is a side, not a diagonal. How many sides are there? 6 sides are there. 6C2 minus 6 are the diagonals. What does it mean? 6 into 5 upon 2 minus 6, it is 15 minus 6, it is nothing but 9 diagonals can be made. So, basing on this, you understand now how n-sided polygon can be considered to find out the diagonals. So, diagonal requires 2 points. N-sided polygon will have n vertices. From n vertices, how many I need to form the diagonal? 2 I need. So, NC2. But in these diagonals, n are sides. These diagonals, n are sides. So, NC2 minus n. So, it should be like n into n minus 1 upon 2 minus n. So, what should it be? N by 2 taken common, n minus 1 minus 2, which is nothing but n of n minus 3 upon 2. Understand it please clearly. So, the number of diagonals that can be formed from an n-sided polygon is nothing but n into n minus 3 upon 2. That's what you can see there. So, you can understand that the number of, this is a geometrical application of combinations, that is n into n minus 3 upon 2. Come to the second one. The number of parallelograms formed when a set of m parallel lines are intersecting another set of n parallel lines is MC2 into NC2. MC2 into NC2. What does it mean? There are one set of parallel lines like this. And this is given to be m there. And another set is there. And this is given to be some n. Understand, to form a parallelogram, either this or wherever you take to form a parallelogram, how many sets of parallel lines we need? This is one set, this is another set. One set is to be chosen from m, another set is to be chosen from n. Understand? So, first operation of selecting two lines from M can be done in how many different ways? MC2 different ways. Second operation of choosing two lines from N can be done in how many different ways? NC2 different ways. So, MC2 into NC2. First operation, second operation. So, the number of diagonals that can, the number of parallelograms formed from a set of m parallel lines and from the set of n parallel lines. M and n is nothing but MC2 into NC2. What is this 2 here? We are choosing two lines from the first set. We are choosing two lines from the second set. And first operation, second operation simultaneously can be performed in MC2 into NC2 different ways. Understand this carefully. Next slide please. If there are n points in a plane, no three of which are on the same straight line, excepting p points, which are collinear, then the number of straight lines formed by joining them is. Follow that carefully please. If there are n points in a plane, how many points are there in the plane? N points. It's a problem. Let us suppose there are n points on a plane. From n points, no three of which are on the same straight line, excepting p points which are collinear. All the points are not lying, no three of these are lying on the same line, but only p points are lying on the same line, like this. Let me say, these are p points. Totally how many points? You can see the slide there. N points are there on the plane. From n points, how many points can be chosen to form a line NC2? Understand? To get a line, how many points are needed? 2 points are needed. This is 1, 2, 3, 4, 5, 6, 7, like that. How many lines can be formed? NC2 lines can be formed. But the problem is here, all these P points are lying on the same line. That means they will not form. They will not form PC2 lines, but they form a single line because they are all lying on the same line. So understand, these PC2 are also included in this one, but they are not PC2 lines, but they are one line. That is why it is to be subtracted, NC2 minus PC2. But the entire P points form a single line. That single line is of course to be added, so plus 1. So when on a plane n points are there, among them P points are collinear, then the number of lines that can be formed are NC2 minus PC2 plus 1. Understand? So similarly, number 2, the number of triangles formed by joining them is number of triangles formed. To form a triangle NC3, to form a triangle NC3, you know that, because to form a triangle how many points we need? 3 points we need. So 3 points are chosen, minus these P points will not form a triangle, but they form a straight line. So minus PC3, minus PC3. So you can see that. Now the number of triangles formed by joining them is NC3 minus PC3. So understand this is also a geometrical application of combinations. Like this, you just think of applying the combinations for the geometrical applications. Let us work out a few more problems on that one. Go to the next slide. So now, if you see the problem on the PPT, please. That one, if a polygon has 35 diagonals, then the number of sides of the polygon is. Can you try that one? Please try that one.